Okay, review for test 7. Uh, Tanya's scores during her ninth grade were the following. Test scores. Create a histogram, and it says start with the interval 50 to 59. So that means we're going to put 50 to 59 here. We could put it on the side too, because it could go either way. So on the bottom, we're going to put the intervals. So it'd be 50 to 59, so I'm going to go 60 to 69, 70, 79, 80 to 89, 90 to 99. And that's all we need because no scores are in the hundreds, so that's it. So then we look at all the 50s. 1. So mark it at 1. This is the frequency. This is a frequency. That means how many scores were in each interval. So 60 to 69, you have 1. 70 to 79, you have 1, 2, 3, 4. 80 to 89, there should be 5 of those, and you can count those, and then 90 to 99, there's 2 of those. So this is the histogram for the test scores. Okay, true, false, maybe. Set A has a higher median. So median is our middle line, and here's A. Set A is higher for a median. That is true. Set B contains more data than set A. So here is set B and here is set A. The range is bigger on set B, but that doesn't mean that there's more numbers for set B. So I could have only 5 numbers here, but I could have 10 numbers in the data for set A. So really we cannot tell for set B containing more data. So this is going to be maybe. We can't tell. Set A has a larger range than set B. So we're talking about the range now. Remember, so that's from low to high. And the range on B, low to high. Is A larger than set B? Well, we're talking from here to here and here to there. So set A is not larger, it's smaller. That's false. Set A has a smaller interquartile range than set B. Interquartile range is the box part, so it's from here and here's B. So it says A is smaller than B, and that is true. Sarah had the following test scores on her 7 tests. She knows that she needs an average of 80 to get a B minus. What's the lowest score she must get on her next test to get a B minus in the class? So the way that we find the average is we add them all up and we divide by how many there are. So we would add up all these test scores, all 7 of them. But then she's taking one more test. So she's taking each of those test scores, adding them up, but then she has one more test to take, and we don't know what she's going to get on it. We want to find out what does she have to get on that test to be able to get her B minus. So we would take not just 7 scores, but we would be taking 8 because we have that unknown test score that we are trying to find out what she has to get on. So if we add up the 7 test scores, we would end up with 540 plus the test we don't know what she scored on, and then divide it by 8. So I'm going to get some room here to write that out. So we got 540 plus x over 8, and we want that to equal 80%. She wants 80% as the average. So we want it to equal 80. So if I'm going to solve this, you can put a 1 under the 80 and you could cross multiply here. Or really it's just times the 8 and the 80 together. So you get 640 equals 540 plus x. And if I want to solve that, I minus 540 over minus 540. So 640 minus 540 is 100. So she's going to have to get 100% or a score of 100 on the next test, which is going to be pretty hard, but that's what she has to get if she wants to get a B minus in the class. Okay, the average age of employees at a store is 25. The box and whisker plot shown represents all the ages of the employees at the store. Fill in the ages for the employees 3 and 10 so that the ages match the box and whisker. So we first need to see what are these numbers in our box and whisker, because we need to match it to that. So first we got about 16, it looks like, because it's bigger than the 15. So we got 16, looks like 20. Then we got 24 and 30 and 40 for the max. Next, we're going to list out all of these ages from small to big that we know in our chart. So we've got 16, 17, 18, we got 22, 22 again, 24, 24, 25, 32, 32, and 40. So again, I just don't have room, but you may want to just write that all right here. Okay, so that, oops, we don't have 40 in our chart. I added that in afterward. Okay, so one thing that we know is that the minimum is 16 and the maximum is 40. So we have a minimum of 16 and a maximum of 40. So I do have to have the 40 in there. We are missing that age. So I'm going to put that on employee 3. I could write it for employee 10 if I wanted. It doesn't matter which one's which. So that's an age we have to put in there so that it matches our chart. Then I got the number, these are all our middle numbers. So 24 needs to be the middle. The number 20 needs to be the middle on this side here of the lower half. So if I'm looking at these numbers over here, the number 20 would be in between 18 and 22. And then I would have, let's see, I would have 3 numbers here, and I would have 3 numbers here. So it looks like the middle is in between 24 and 24. So we got the middle number there, 24. And then I need the other middle number to be 30. So that would be, let's see, I would have to have 3 numbers and 3 numbers. So I'm missing a number in this section right here. So it needs to be 30 for the middle. So I need to add in a number right here so that the middle number between the two numbers is 30. So I've got 32, and I'd have to have what number right here so that the middle number of both of those is 30? Well, 32 is 2 away from 30, so 30 minus 22, or minus 2, is 28. So it looks like the other age that I'm missing is 28. And if you wanted to now, you could plug those numbers in on the calculator and figure out if those are accurate numbers for the box and whisker, and just check and make sure. What percent of employees are at least 20 years old? So 20 years old is right here. That's our first quartile. So we have 1, 2, 3 quartiles. So it's 25% plus 25% plus 25%. So that means 75% of the employees are going to be 20 years or older, because box and whisker, each section is 25%. So the next part says Class A had quiz scores given. Create a dot plot for the data. Dot plot is not a box and whisker. Dot plot is when we just mark each of the numbers. So there's 1 5. I'm going to put X's to mark it. There's 1 6. There's 3 7s. There's 3 8s. So dot plot should be a piece of cake. There's 5 9s. And there's 2 10s. Then it says find the mean. Mean is where we average. That's the same as average. You add them all up and divide by how many there are, or you can use your calculator. And the calculator will give you X with a bar on top, and it'll tell you the mean is about 8.07. Or if you add them up and divide, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So we'd add and divide by 15. The median, well, maybe we want to create a box plot first, and then we can find the median, because that would make it easier. So if I write these out from small to big, I got them listed here on my dot plot. So I have 5, 6, 7, 7, 7, 8, 8, 8, 9, 9, 9, 9, 9, and there's 2 10s. I gotta move this, not that. I gotta move these numbers over. Well, that's not what I want to do. Okay, so 10 and 10. So if I find the middle here, or you can, again, you can do this on your calculator. The middle number is going to be 8. Then we got a max at 10. We got a min at 5. And from there we would have a middle of this half. Let's see, 1, 2, 3, 4, 5, 6, 7. Middle of that half. Middle of that half would be 7 here, and then a 9 over there. So 7 and 9. And that's our box plot. So the median is 8. The range is 10 minus 5, so it's 5. Ranges from big to small. The standard deviation is the sample data, so S, that SX, if you type it in, is 1.44. Okay, then Class B, what we're going to do with this is we're going to be comparing it to Class A. So we're going to create a box plot and then compare it to what we did on number 5. So we've already got the numbers in order. All we need to do is make a box plot. So 4, 5, 6. 1, 2, 3, 4, 5, 6, 7.